All right, hello everyone. Welcome to a lesson on 6.2, something called standard form of a line. Now, the last lesson, if you recall, was slope, y-intercept form of a line. So we went over one way to represent a line, and now what we're going to do is go over a second way, which is called standard form. So standard form of a line. It's just another way to name your line. So we will be using 6.2 handouts today, so make sure you have those out and you can copy them out. You do have a little bit of homework, 1 to 5 and question 10 on page 312. But to get us started off, I figured I would just review slope y-intercept form of a line very, very quickly. So you don't have this page, it's just something to get our minds going here. So pause the video and just see if you can match up what equation of a line goes with which line over here. So see if you can match them up, and when you think you have them, just unpause and you can see if you were right. Okay, welcome back. So the first one, y equals 2x minus 3. The second one is y is equal to 6, y is equal to negative x plus 4, and x equals negative 3. Okay, this very first one is not a vertical line, it's not a horizontal line, it's not one of our special cases. It either slopes up to the right or down to the right, and because 2 is positive, this one slopes up to the right. Our m value in front of the x, this is our m, is positive. Y equals 6 is one of these special two cases, and because it's y equals 6, it's a horizontal line. So this one is a horizontal line at a height of 6. Y equals negative x plus 4. Because of the negative in front of the x, that is a line that slopes down to the right. And finally, x equals negative 3. This is the only equation of a line that starts with a x, not a y. This is your vertical line. The slope is undefined. We've got a vertical line. Okay. Next, a line has a y-intercept of 2 and a slope of 3 over 5. Explain how you can use this information to graph the line. Okay. How do we graph a line if we know the slope is 3 over 5 and the y-intercept is 2? Well, we are going to start at our y-intercept, which is 2 right here. And again, you do not have these pages. It's just a minds-on activity to get you kind of refreshed on 6.1. Our slope is 3 over 5. The only issue I see is, do you see how we're going up by 2's? So if I want to go up 3, I would have to go up 1.5 lines, and I get somewhere in here. So the only thing I'm going to bring your attention to is if you have a slope of 3 over 5, you can double it, and it's the same as having a slope of 6 over 10. These are the same slopes, okay, rise over run. So what I did was I doubled it because now it's much easier to start at 2 and to go up 2, 4, 6, which is all the way up to 8. So we rose 6, and now we're going to run 10, and we'll put our next point. So if our next point is right here, and we started here, then we can easily draw our line, which is from here all the way through, and there's the equation of the graph of the line. So how would I graph it? I start at my y-intercept, and then I use my slope to get to another point. Okay. Next, take a look at this little graph here, and I'm going to hide the answers. This is just a distance time graph in front of a motion sensor. So the distance time graph of a person walking in front of a motion sensor is shown. First question, at what distance did the person begin walking? When I look at this, I see that we start right here at 2, and it says explain. So I put 2 meters away because that's our y-intercept. At time is equal to 0, our distance away is 2. Next question, were they walking towards or away? This line goes up to the right. It means our distance is getting farther away, so we're walking away because the line goes up to the right. Next, how fast was the person walking? That's a rate of change. How fast were they walking? We want to find the slope of the line. So what I did was I drew in from here. I went over 2, and I went up 3. And basically I said that this line has a rise of 3 and a run of 2, but they want to know how fast the person was walking. They don't want the slope, they want the rate of change. So I went 3 divided by 2, rise over run, 3 divided by 2, and I got 1.5 meters per second. That's what they want right there when they start talking about how fast they were walking. You don't say, how fast were you walking? 3/2. How fast were you walking? You say, I was going 1.5 meters a second. That makes more sense. Write the equation in the form d equals mt plus b, or y equals mx plus b. So I went and I put d is equal to 1.5t, that's my m, plus 2 is my b. Now, if you wanted to, because of this equation, put 3/2, that's fine, but know that 1.5 and 3/2 are the exact same. Okay? And then lastly, actually, that's the last one I'm going to do. So that's just kind of getting us off on the right foot. And now we're going to go in. This is the first page that you actually have in your notes. Okay, so if you can grab this page, it's an investigation. Usually I do that in class, but today we're going to start with this page right here. So this investigation is just to get our minds going with the standard form of a line. So you can fill this out and pause the video as we go through here, okay? So the very first thing, it says, consider this equation, 3x minus 4y plus 8 is equal to 0. And usually what I do in class is I say, do you think this relationship is linear or non-linear? And I kind of have a little bit of comparison. I count how many kids think it's linear, how many people think it's non-linear. So I usually get some pretty good answers here. People have some pretty in-depth thoughts, which is great. What would you put, just kind of think to yourself, would you say that this is linear when you graph it, it's a straight line, or it's non-linear when you graph it, it's not a straight line? And just kind of get your thinking as to which one it is. Through this investigation, we will see exactly what it is. So just kind of get that. Next, find the y-intercept. Well, just know that whenever you have a y-intercept, it's always at the value of x is equal to 0. So if you have this graph and you're trying to find your x or your y-intercept, your x value is always 0. So really all we have to do is plug x is equal to 0 into this equation and solve for y, and it tells us exactly what our y-intercept is. So we're just going to take this equation and plug 0 in for the x value and then just solve for y. So we go up to this equation and we say, well, this x now becomes a 0. So when I multiply 3 times 0, that goes away, and I'm just left with negative 4y plus 8 is equal to 0. And we know how to solve this equation. We bring the 8 to the other side, we divide by negative 4, and we get 2. So when I plug x is equal to 0, I get y is equal to 2, and that makes sense that I would go up 1, 2, and I would put a point right there on my y-axis because that's my y-intercept. So I know this point. Next, find the coordinates of 2 other points. Now this is something that's difficult even if you're in class. So I'm just going to explain it. What you want to do is take the equation and find an x and a y so that when you actually plug in an x number and a y number, this equation is true. And the way to think about it is this right here. If you can find an x value and a y value to plug in, and this thing becomes true, then you know you found a point on the line. So some of the points that I found were this: 4 and 5. So picture putting a 4 right here and a 5 right here. 3 times 4 is 12. Negative 4 times 5 is negative 20. So 12 plus 8 is 20. We take away 20, that gives us 0. This works. Same with 8, 8. So I put an 8 here, I get 24. 3 times 8. I put an 8 here, I get 32, but it's a negative. So 24 take away 32 is negative 8, and then I add 8 and I get 0. These were the 2 points that I came up with, although there's more. But please note that you just have to find an x and a y to plug into this equation so that when you go 3 times this number, take away 4 times this number, and then you add 8, you get 0. That means you found a point on the line. So the next part says plot all 3 points that you have found on your grid. And you guys have a grid there, and I'm going to start with 2, 0. That was the very first point that I found, the y-intercept. So let's plot that point. I'll use green right here, so 2, 0, right there. Next, I'm going to plot 4, 5. So over 4 and up to 5. There's another point on my line. And lastly, 8. So over to 8 and all the way up to 8. There's a point on my line. And it says draw a line through these points. Well, I'm going to start here. I'm going to draw a line all the way through, and notice that we get a straight line. This is actually linear. So when you were asked up here, is this linear or non-linear? Well, this makes sense that it is now linear, and we know it's linear because when we found points on the line and plotted them, they all formed a straight line, which is really cool. So we did that part. Use two of these points to find the slope of the line. Okay, well, if I use the first point and the second point, I have a run, 1, 2, 3, 4, so a run of 4, and a rise of 1, 2, and 3, so a rise of 3. So if I were to use these 2 points and find a slope, whether it's 4 over and 3 up, or whether you use the second point, you went 8 over and 6 up, you're still going to reduce this down to a rise of 3 and a run of 4. So that's what I got right there. And then the very last part says use your slope and y-intercept to find the equation of the line. Well, the slope and y-intercept, I already have the slope, 3 over 4. The y-intercept is 2, I found that. So I just plugged into y equals mx plus b. My m is 3 over 4. I found it from the graph, and I know my y-intercept is 2. So now that we have these, it says compare what is the same and what is different. Now let's slow down and let's just understand what this investigation was about. This investigation took this equation. If you see this equation, it's way up here. This is the very first one that I gave you. So we were talking about this equation, and it's not in the form y equals mx plus b. If it was, I know what my slope is, I know what my y-intercept is, and I know it's linear. But this isn't in that form, y equals mx plus b. So we found our intercept, our y-intercept. We found 2 more points on the line. We graphed those points onto a grid, and we put a line through them. We said, wait, this is linear. Holy cow, all the points line up. So if it's linear, we can find our slope, and we did. We can use our slope and our y-intercept to come up with the equation, and this is Mr. Bracken right here, and through a little bit of work, we got down to Dave. These two are the exact same line. This is Mr. Bracken, and this is Dave. These are twins. They're the same. But from this line right here, I don't know anything about the slope or the y-intercept or nothing. But from here, I know my slope is 3 over 4. Rise, run. I know my y-intercept is 2. If you wanted me to graph this thing, I know how to graph this. I start at 2, I go up 3 over 4, put a point, I can put a line through it. I know way more if it's in this form than in this form. Mr. Bracken isn't good, Dave is. So our whole lesson today is if you have an equation like this, let's learn easily how to put it into this form, and then we know everything about it. And notice that we're just trying to get the y all by itself. So that investigation isn't the important part. The important part is the back side of this page here. So this is called a standard form of a line. I'll go back here. This is the standard form of a line. This is the slope y-intercept form. We're going to put standard form into slope y-intercept form. So standard form of a line is the format of ax plus by plus c is equal to 0. So if you were to take a look at this equation right here, and I'm going to grab it still. So come with me, copy, and go over here, and I'm going to paste it. Do you see how this follows this template? The a is a 3, the b is a -4, and the c is an 8. But this is in standard form, ax plus by plus c is equal to 0, where a, b, and c are integers. And what that means is there's no decimals or fractions. These numbers will never be fractions or decimals. They're always integer whole numbers. Now, a couple other things are a and b are never both equal to 0. Okay, that's just something we have to put in for later on, more so than right now. But you can convert an equation in standard form, in this form, you can put it into slope y-intercept form just by rearranging the equation. So we can take something like this and quickly put it into this form so we know everything about it. And that's what our lesson is today. So here's what we're going to do. We're going to express each of these in the form y equals mx plus b in slope y-intercept form. These are both given in standard form. So the first thing that I'm going to do is I'm going to move the x over to this side and the minus 4 over to this side. And what happens when I do that is x becomes negative x on this side, and negative 4 becomes positive 4 when we move it over the equal sign, just like when we were solving equations. Now I've got the 2y all by itself. And the last thing I'm going to do is I'm going to divide these two things by 2. So this negative x gets divided by 2, and this 4 gets divided by 2. Both these terms get divided by 2. When I do that, this right here is a weird form, but negative is just like a negative 1. So negative 1 over 2 of these x's, I took the x out of the fraction, and 4 divided by 2 is just 2. Now, this is Mr. Bracken, this is Dave. I know the slope, negative 1 over 2, and I know the y-intercept, which is positive 2. This is standard form, slope y-intercept form. We want to get it into this form right here. We know a lot more about the line. So first one done, hopefully that made sense to you. Next one. I want to get the y all by itself. See how the y is isolated here all by itself? I want to get this y by itself. Now you could do what we did over here and put the 6x and the 15 over here and change the sign, but I'm going to move the negative 3y over to the other side. The reason is I just made it positive. Do you see the positive 3y now? So to go to my next step, I want to get the y by itself, so divide the 6 by 3 and the 15 by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So I have 2x, take away 5 is equal to y, or I can just spin this around and say y equals 2x, take away 5. Now this is in slope y-intercept form. The only thing I know about this right here is it's linear, but I don't know the slope and I don't know the y-intercept. But when I move the y over, I divide by 3 and I get it in this form, my slope is now 2, or 2 over 1. Rise is 2, run is 1. My y-intercept is 5. So I can start down at negative 5, I can go up 2 and over 1, put a point, up 2 over 1, put a point, I can graph this thing. I know a lot more about it. Okay, let's keep moving. Celebrations. Banquet hall uses the equation 25n minus c plus 1,250 equals 0 to determine the cost of a hall rental. C is the cost, and n is the number of people. Let's put this in slope y-intercept form with the c all by itself. C equals how much a person plus how much up front. There's a real easy way to do this. Just take your equation and move this subtract c to the other side. It becomes plus c. And then we can just spin it around. The cost is actually, that should be an n. The cost is $25 a person plus $12.50 up front. So identify the fixed and the variable cost. Well, the fixed cost is just $1,250 up front. That's probably to rent the hall. The variable cost is $25 a person. It says make a real quick sketch. Now you can make scales down here and scales down here, but by a quick sketch, all I want you to understand is we have an upfront cost, so we're going to start up here somewhere, and it's $25 a person, so our line's going to go up to the right. That's all I want you to understand with this quick sketch is we start above, we've got a fixed cost of $12.50, and we go up to the right. We don't have to worry about the scales on this one. What if 100 people attended this soccer banquet? How much would it cost? Well, I'm going to take my equation, I'm going to plug in 100 for the number of people, and when I multiply it out, I get 3,750. So that basically brings us to the end of this unit, of this chapter. Now, let's just refresh what's going on with this. The whole purpose of this is to take something that looks like this, and I'm going to bring this from our former investigation, our previous investigation. I'm going to bring this all the way to the bottom. And what I'm going to do is I'm going to say, okay, we want to put this in the form y equals mx plus b. I know it's linear because there's no exponents. That's key. I know it's linear. But how do I put this in that form? So the first thing I'm going to do is I am going to keep the 3x here. I'm going to keep the 8 here, but I'm going to move the negative 4y to the other side. It becomes positive 4y. Now I've got the y term by itself. So I'm going to go to the new line, and I've got to divide 3 by 4, and I get those x's, plus I've got to divide 8 by 4. So the 3 gets divided by 4, the 8 gets divided by 4, and then what that does is it gets rid of the 4 over here. And then the very last thing is I can just take this and I can go copy, paste, and I'm going to bring the y in front. Sorry, one sec here. I'm going to bring the y in front. I'm going to go y equals 3 over 4x plus 8 over 4. But 8 over 4, forget this y equals now, that just becomes 2. So what I did was I brought the 4y over, became positive. I divided both of these by 4. And then what I did was I said 8 divided by 4 is 2. I'm not going to divide this because it doesn't work out even. And I'm just going to put y equals instead of equals y on the end. These two are the same. And if I were to copy this and go to our investigation, if I were to paste this, you see how we went from this 3x minus 4 plus 8 over to this real quickly instead of doing this whole investigation? Just get the y all by itself. So move the 4y over in this case because it was negative. I made it positive, divide by 4, and then reduce it down. And you now know this standard form of a line, you now know more about it with the slope and the y-intercept. So that's today's lesson. Try it. We will take up any difficulties in class. I'll probably even post a video showing the solutions to your homework from 6.1 and 6.2 tomorrow. I'll have a video showing all of the solutions. So right now, I just want you to try it, see if you have any difficulties, and reach out to me in EDSB if there's any issues. So hopefully that makes sense to you. Your homework is on page 312, questions 1, 2, 3, 4, 5, and question 10. Put all of them in slope y-intercept form. So thanks everyone, and talk to you guys soon.